Our platform is intended to perform analysis and visualization of public spending and tender data to make public procurement more efficient and transparent. First part of platform is used for analyzing financial transactions. We are using several anomaly detection methods: clusters, periods, derivatives, and cumulatives. Anomalies are detected in the whole dataset or in different industry sectors only. The data about financial transactions are from application ERAR, which is showing all financial transactions from Slovenian public sector to private companies from 2003. Let's take a look to different anomaly detection methods. Clusters, or 1D clustering method, organizes transaction sums into an optimal number of clusters and defines deviations within each cluster separately. Therefore, this method performs data clustering in order to determine the best arrangement of values into different classes. The method is seeking to minimize each class's average deviation from the class mean, and at the same time it is maximizing each class's deviation from the means of the other groups. So method clusters the data in a manner that it reduces the variance within classes and maximizes the variance between classes. As already mentioned, we can analyze the whole dataset or select a specific industry sector. For instance, if we select computer programming, consultancy, and related activities, we can quickly spot a company called K8 with the highest anomaly score. If we take a look into the ERAR application, we can see a great deviation in payments to that specific company in July 2020. Periods or period margins method works the following way. First, we are defining a financial transactions as a base relation between two entities, public sector entity and business entity. Based on this, we detect relation periods when relation started or ended, and then accumulate starting or ending periods on a timeline. Based on cumulative relation period extremes, we identify deviations and list entities as part of identified extremes. In a timeline, we can see time points where anomalies are culminating, and we can correlate that with historical events. For instance, economic and political crisis around 2012, migrant crisis in 2016, and of course COVID-19 outbreak in 2020. We can also check anomalies for specific industry sectors. For instance, if we select construction of buildings, we can see a lot of anomalies in 2020 during the COVID crisis. This would be explained by the fact that the Slovenian government and local communities launched a lot of construction projects during the crisis. Local extremes or derivatives method analyzes the biggest changes within two entities and transactional relation in a given period. If a change is identified as an anomaly, it is added to the cumulative anomaly graph. Once cumulative anomaly graph is defined, based on all transactions jumps between the two entities, extremes are identified and therefore anomalous companies are identified. The purpose of the method is to identify the companies manifesting biggest changes in transaction relations. On a graph, we can see how the number of anomalies in public spending increased every beginning of the budget year after local and parliamentary elections and so on. We can also see a change after 2014 when Slovenia overcame the economic crisis. If we select human health activities, we can also see the rise of cumulative anomalies during COVID pandemic. The last anomaly detection method is partial cumulatives. In this method's approach, we first define transaction sums for all related entities and normalize sums with the total transaction sum. In such way, this method defines a comparison baseline. Then it takes transactions between entities, and sums them into a predefined number of periods. For each period, partial sums weights are compared to the baseline weights and anomalies are identified. The more anomalous a company behaves, the higher it ranks on the anomalous list. The purpose of the method is to identify the biggest changes within the series of accumulated periods. If we select human health activities, we can see a company for physiotherapy which has the highest anomaly measure within health services. A quick look into RR database visually reveals anomalies in payments to this company. Another part of the platform is focused on anomaly detection in tenders. We have implemented several anomaly detection methods. However, on the main page we are presenting common anomaly rank, which is synthetic anomaly measure. Companies with higher value enforce higher anomalous behavior. If we select one of the most anomalous company, we can see that the company has 0 employees, but has won 255 tenders, and all of them from one public entity. A quick look into RR database shows that the company received more than 200,000 euros of financial transactions. Let's take a look what anomaly is in the case of ratios analysis. Here we are comparing revenue and the number of employees. As we can see in the middle of the curve, the trend is close to linear, which we consider a normal behavior. While on the curve margins, we can see the ratio starts to deviate from the linear trend. On one side, we have positive deviations and on the other, negative deviations, which we can further explore on the tabs. Let's take an example of positive deviations. Here we see the 5% of most deviating ratios, which we call anomaly. These anomalies are weighted. The more the ratio is higher, the more anomaly is rated and brings more to the company anomaly index. For example, if we take the highest ratio, we can see one company, Bidder, which has one employee only and has received 83.1 million euros from the Slovenian nuclear plant. However, not all anomalies imply illegal or illicit actions. In the given example, the bidder has been a foreign company with representative office of the company in Slovenia, which has one employee only. The Deviations knowledge graph is integrated in the platform as well. You can select different datasets and you can see the tender data from the knowledge graph. Another analysis to detect anomalies is budget assess. Here we are comparing overall distribution and company's own distribution of number of bids received per tender. We can also compare distribution of difference between assessed and final tender value. We have implemented several supervised and unsupervised analyses. Here we will briefly show the unsupervised method, which is accessible under the clusters. We can do analysis and visualization of different variables. Let's take a look how company size is related to final tender value. At the bottom side of the graph, we can see the small companies which won small tenders. On the top right side of the graph, we can see the big companies which won big tenders. We can also see a group of small companies which won relatively big tenders, which could be anomaly. Another anomaly detection method is distributions. This method calculates the normal distribution of number of bids per lot received for the whole dataset and compares that with the company's own tender winning distribution. A large skewness towards majority of tenders won when one bid was received might indicate a problem. Dependencies method shows the dependency of either a contracting authority towards economic operator or vice versa. With this method, we can initiate companies or public sector entities which are too dependent from each other, which may indicate vendor lock-in or some other unwanted behavior. Decision tree learning is a predictive modeling approach which uses a predictive model to go from observations about an item to conclusions about the item's target value. In other words, a decision tree shows us a model of decisions and their possible consequences. Our platform allows users to select fields from public procurement database that should be analyzed and depth of decision tree model. Platform then computes decision tree model and presents it on the screen. The last section of our platform is a module called Streams. With this module, we can export public procurement data into the Stream Story tool, which is intended to help with analysis and interpretation of time-varying data. With this tool, users can easily uncover the dynamic of the public spending and spot irregularities and anomalies in public spending data. The details of Stream Story tool are presented in a different video presentation. Our platform is being actively developed. It can be used by buyers, decision makers, and control authorities, data analysts, and data journalists to explore and understand the complexity of public procurement.